Begin here looking at some more information with vectors. Let's go ahead and review what we had done on the previous video, the beginning of section 6.3. Find the component vector of a vector from 0, 0 to 3, negative 2. Well, when you do component form, the component form looks like this, and the way you find it is you take the end of the vector and subtract the beginning of the vector. So 3 minus 0 is 3, and negative 2 minus 0 is negative 2. So this is the component form for that first vector. So the component form for the second vector, again, you take the end of it, 6 minus 3. It's like you're finding the displacement. And 1 minus negative 5. Those are the component forms. All right, finding magnitude. Magnitude of a vector is the distance. You use the distance formula. So you can go ahead and do component form first. Okay, so 5 minus 3 is 2, and then 5 minus negative 1 is 6, and then magnitude, so if this is vector v, the magnitude of it would be equal to the square root of the 2 squared plus 6 squared, which is 36 plus 4, so square root of 40, or write that as 2 square roots of 10. So you do the distance formula, and obviously what you can see here is in the middle of the distance formula you are finding the component form. All right, the last problem here, just to review, is let's find v plus w. W here, let's make this w. Vector v plus vector w. Well, what you can do is you take vector v, which let's go ahead and vector v is already existing here, okay? And then vector w is right here. This is one way to do it. You create that parallelogram. Now the sum of the vectors is from the start of both vectors to the diagonal all the way up to where the intersection of the rest of the parallelogram would be. So there's one way to do it. Okay. Another way to do it is you start with v, and then you continue from v, you put w out there, and then you still do the diagonal. So this is v plus w. This is v plus w. All right, so those are a few things that we learned in the previous lesson related to vectors. What you're going to find is there's some information here that's going to help us get through the next few pages. This is not in your packet, but it may be something that you want to write down somewhere. A unit vector. A unit vector is a vector that has magnitude of 1. So the 1, that's why we call it a unit, like it's a 1-unit vector. To find the unit vector of a vector v, this is the result of it, okay? So the unit vector, u, is equal to the vector v divided by its magnitude. So you do vector divided by magnitude of the vector. Now the result of it is another vector. The result is another vector, okay? All right, so you're going to want to take this right here and make sure you write down the formula. Other important things before we lead into some of the operations and finding the unit vector is that there are two important vectors, and they are vectors I and vectors j. Vector I is a unit vector. These are both unit vectors. Vector I is the vector 0, 1. Okay, so again, here we got some unit vectors, and I had a typo here, so I just try to adjust some things. We've got two unit vectors. One of them is vector, let's go with vector I first. Vector I, right here, is the unit vector 1, 0. So here's the unit vector 1, 0. Right there. That's the unit vector. So you can see the magnitude of it would be 1. And the unit vector 0, 1 is j. That's this vector right here. Okay, so you can see that they're just 1 unit in length. These vectors can be used to represent any vector. So if you got vector v, where you have v1, v2, and these are again just locations, then you can represent the vector by taking the information and putting it into what's called a linear combination form. Linear combination, instead of having a vector of, let's say, 2, 3, then what we can do is write it as 2i plus 3j. Okay, so this is your component form, and this is the linear combination form. That's all this is representing, is that you're going to see your vectors written in different forms, and with the I and the j, and all it is it combines and writes your first part of your vector with an I. The first component goes with the I, it's like the x part, and the second component part goes with the j, which is like your y value. So the vector sum, vi plus vj, is called the linear combination of the vectors I and j. All right, so again, you're going to see some of your vectors represented in this form. Either one of these forms, it's fine. All right, example 4 now. This is in the packet. We are going to find v plus 4u. So you're going to be given some vectors. The vectors are in bold, and there are ways that you just add, subtract. You can do scalar multiplication with the vectors. And so if I do v plus 4u, then I'm going to take negative 3 plus 4 times 0. Negative 3 plus 4 times 0. You just pair up the component parts, and then it's going to be 9 plus 4 times negative 5. So my result to this is going to be negative 3, comma, negative 11. That's your final answer. All right, if I have u is equal to 2i minus j and v is equal to negative I plus j, see these are in linear combination forms. We can still do this, but I'm going to go ahead and put my answer in linear combination. So we have v, so v is negative I plus j plus 4 times u. And I'm going to go ahead and substitute u in here, 2i minus j. What I'm going to do is distribute, so I've got negative I plus j plus 8i minus 4j. Negative I plus 8i is 7i, and j minus 4j is minus 3j. So 7i minus 3j, this is the result of that vector. All right, so you can do any kind of operations here with your vectors. Using unit vectors, finding the unit vector. The unit vector, again, is the vector over the magnitude of the vector. So let's go ahead and look at this. So I've got the vector. The vector is 3, negative 4 over the magnitude. So the magnitude would be the square root of 9 plus 16. I've just squared both of those. Since this is in component form, you square it, add them together. This would be the vector 3, negative 4 divided by the square root of 25, which is the vector 3, negative 4 divided by 5. We actually will write the result of this as 3/5 and negative 4/5. So this is the unit vector. All right, we are going to go ahead and try another one of these unit vectors. I'm going to be given let's see here. I'm going to be giving you the information. So this is example 5B. Example 5B, and the unit vector is I minus 2j. We're going to find the unit vector of this vector, I minus 2j. Well, this vector in component form would be 1 comma negative 2. That's what that would be. So if I take the vector and I divide by the magnitude, it would be 1 squared, 1 plus negative 2 squared, which would be 4. This would equal 1 negative 2 over the square root of 5. Okay, so we have, I'm just going to keep simplifying this, 1 over the square root of 5 and negative 2 over the square root of 5. This would equal, you have to rationalize this, you can't leave it in that form, square root of 5 over 5 and negative 2 square root of 5 over 5. That's your final answer. So this is the unit vector here to the beginning. The beginning just happened to be in linear combination form. All right, let's go ahead and look at our next example, example 6. It says find the vector v with the given magnitude and the same direction as u. Well, the way that we're going to do that is right here. You take the magnitude of the vector v and you multiply it by the unit vector of u. So the first thing that we need to do is we need to find the unit vector. Let's find the unit vector of u. So the unit vector would be 4, negative 4 divided by the square root of, you do 4 squared plus negative 4 squared, so that's 16 plus 16. So this is 4, negative 4 over the square root of 32. We need to simplify this. 4, negative 4 over the square root of 32 can be written as 4 square roots of 2. All right, so I'm going to keep simplifying this. I'm now going to come back here to the other side. If I go ahead and divide both of those, what I have is 4 over 4 square roots of 2 and negative 4 over 4 square roots of 2. Simplifying this all the way down, the 4's cancel here, the 4's cancel. I would rationalize this. We get root 2 over 2 and negative root 2 over 2. All right, so this is the unit vector, okay? And finally, again, what we have to do is you take the magnitude times the unit vector. So my magnitude is 3. So I'm going to take 3 times my unit vector. So the final answer is 3 square roots of 2 over 2 and negative 3 square roots of 2 over 2. There you go. That is my final result. So what you're trying to do is you're trying to find another vector that has the same direction but just with a different magnitude, a magnitude of 3. All right, let's try this again. We start with our vector of 2i minus 3j, so I'm going to turn that into component form, 2 comma negative 3. We're going to find the magnitude, so divide by the square root of 4 plus 9, that's 13. This ends up being 2 over the root 13, negative 3 over the root 13, and that would simplify to 2 square roots of 13 over 13, and negative 3 square roots of 13 over 13. Okay, there's the unit vector, and your final step would be to multiply by the magnitude, so multiplying this by 10. So it'd be 20 square roots of 3 over 13, and negative 30 square roots of 3 over 13. So there's your vector. And then I just kept this vector in component form. If you're going to write it back into the linear combination, then it would be 2 square roots of 3 over 13I minus 30, I'm sorry, 20, not 2, minus 30 square roots of 3 over 3J. So either one of those, you got the component form and you got the linear combination form. All right, example 7. A vector has an initial point of negative 1, 5. I like to draw these out. Negative 1, 5. And a terminal point of 2, 3. So there's the vector. Write a linear combination of the standard vector I and j. All right, well, the first thing that you need to do is find component form. So this is where I start. This is the beginning and this is the end. So the component form would be 2 minus negative 1, which is 3, and 3 minus 5, which is negative 2. So I can put that in linear form as 3i minus 2j. That's all you have to do there. You take your vector, the beginning to the end, and you find their displacement. So you subtract, and then write it with I and j. All right, in example 8, looks like we are going to just be working with some operations again. You've got u is 2i minus j and w is I plus 2j. Find the component form of v and sketch. So we're doing v is 2u minus 2w. Let's go ahead and do that. So 2 times u would be 2i minus j minus 2 times w. W is I plus 2j. Let's do all the algebraic parts to this. So this is 4i minus 2j minus 2i minus 4. This is supposed to be a j right there. That's 4j. Adding like terms, 4i minus 2i, so it's 2i, and then negative 2i and a negative 4i is minus 6. These are j's. So this then is the vector 2, negative 6. So sketching that, all right, here's how I'm going to sketch this. I'm going to go ahead and we're going to sketch 2i minus j. 2i would be over 2, down I is down 1. All right, so there's a u. If I want to do another u, I go over 2 again and down 1. So this is 2u right there, 2u. I'll do a different color here for the w. All right, w is I plus 2j, so over 1, up 2. This is a w, so if I do that again, over 1, up 2. This is 2w. All right, now what we know about subtraction. Subtraction is you go to the end of the second one, the end of the second, to the end of the first. End of the second to the end of the first. So this is the resultant vector. This is 2u minus 2w. Okay, it wouldn't be any different if I did this. If I did my vector of 2, negative 6, so over 2, down 6. These two vectors are same direction and same magnitude. Both of them represent 2u minus 2w. All right, I'm going to go ahead and pause with this video, and we'll pick up with the next example on the next video.